Sir, is my screen visible? Hello, am I audible, sir?
Visible, sir.
Now it is visible, right?
Yes, sir. Yes, sir. Visible.
Okay. Shall we start or we have to wait, sir?
You can start, sir.
Shall I start? Shanmugam, sir? Hello?
சார் உங்க ஸ்கிரீன் ஷேர் பண்ணுங்க சார். ஹலோ சார்.
Is it?
Sir, it is visible, sir.
Okay. Yes, sir.
Sir, shall we start the session, sir?
Yes, sir. Yes, sir. Am I audible, right, sir? Am I audible?
You are audible, sir.
Okay. Shall I start or?
Sir, I will introduce, sir, in a brief way.
Okay.
Respected principal, respected today's guest speaker, Dr. G.S. Ram Pradeep, dear participants, good morning to all. Now we are going to have the first session on bendable concrete in structural elements by Dr. G.S. Ram Pradeep, Professor at Kongu Engineering College, Perundurai. Actually, day before yesterday, we have introduced our professor. At that time, I missed to mention one thing. Dr. G.S. Ram Pradeep is the youngest director of American Concrete Institute, Southern Zone of India. He is well versed in concrete. You can contact him and you can utilize him in all aspects. He is very much useful in our part, and also he is very much related to concrete field. Now I welcome Dr. G.S. Ram Pradeep sir to take this today's first session. Thank you, sir.
Thank you, sir. Thank you so much. I will share the screen.
Okay, sir.
Is it visible, right?
It is visible, sir.
Okay. So once again, welcome you all for the today's webinar on the bendable concrete. So in this Atal FDP, this is my second session. Actually, on 13th, I have shared the very most important of special concretes in construction industry. So today, in depth, if we focused, we are going to see the most important concept of the bendable concrete, which is nothing but a thin flexural membrane, right? Already in 13th day, I told you that when we are choosing the topic for the research applications, we need to focus and we need to give the clear problem statement, the clear research gap, what we are going to do in the cementitious material or any other type of concrete or hybrid material, right? So the two things we need to focus is the problem statement as well as how crucial the application of the problem statement will be in the construction industry in future. That decides our publication count as well as obtaining the grant. See, nowadays, if we see that most of the grants are related to one topic. For example, if I am applying for self-compacting concrete, we are thinking that it is an oldest topic, we cannot get the grant or we cannot get the publication. It will not be published in the most reputed SCA journal. Not like that. So it is the way how we are collecting the previous articles and how we are picking up the gap analysis from the already cited journals. As I told you earlier that Okamura and Auchi is the founder of that SCC. If we are doing with, you can also make a hybrid analysis, a blended analysis of the fibers, or you can alter the geometrical parameter or morphological structure of the membrane. Then you can apply for the journals. It can be published. If you take IIT Bombay, the professor Prakash Nandagopalan, he is doing in rheological characteristics of the cementitious composites, right? So in different kinds of applications, you can see a most fine-tuned type of research. So my sincere advice to you all, to the most budding people, is when you are choosing the title, don't go for the same title and same kind of research For example, if somebody is doing in volume fraction of one fiber, you just don't go for the same concept by varying the volume fraction, right? So that is not advisable. So it creates waste of time as well as waste of material, right? So here in this part, we are going to see the bendable concrete in the part of high performance ECC, which was recently developed by our Professor A.R. Krishnaraja in his research under the supervising of Dr. S. Anandakumar. So he recently made his defense and obtained a degree, PhD. So I'm going to present his innovations in the area of high performance ECC using different types of fibers. So usually the fiber is the one, as I already told you in the 13th of July, it is a material which induces the tensile strength as well as it will reduce the crack width. That is called bridging the gap. Bridging, B-R-I-D-G-I-N-G, bridging the gap of the cracks, right? So he has analyzed for a monofiber like glass, steel, polyvinyl alcohol, polypropylene, like that. He has analyzed for monofiber, and in am I audible?
Yes,
you are
sir.
audible, sir.
Okay. Okay. Just a minute, sir. So he developed his analysis for monofiber like steel,
Hemlata Alakar, please
PVA.
mute your phone. Hemlata Alakar. Hemlata Alakar.
Hello. Shall I proceed, sir?
Sir, you can proceed, sir.
Okay, sir. Then he has clubbed 2 or 3 fibers like steel and PVA, steel and PP, PVA and glass, like that. So earlier, when Professor Krishnaraja did his PhD, so he has obtained the fiber from the South Africa. Then he has made the research, right? So now high performance and ECC both are different. We have studied in our concrete technology that the difference between high strength concrete and the high performance concrete. See, high strength concrete is almost equal to ultimate load method. I am relating, right? In RCC, we have studied ultimate load method. So high strength is equivalent to ultimate load method. High performance, how we can classify? See, all high strength are not high performance, but all high performance are high strength. Then what is a high performance induces? High performance relates the strength as well as the sustainability. That is the durability point of view, which should possess all the satisfactory conditions of the durability. It should satisfy the RCPT analysis. It should satisfy the corrosion. It should satisfy the water sorptivity. It should satisfy the water absorption, water permeability, all the classifications, all the kinds of durability tests, including the relative humidity, it should get satisfied. So, I told about the high performance. What about the engineered cementitious composites? So, it is like a thin membrane. For example, if you are normal condition for the conventional concrete analysis, if you are putting 150 mm thick concrete slab, right? So we are calling it as a reinforced slab. But in ECC, we are using only the fibers, randomly distributed fibers in a different volume fraction, and we are analyzing how much flexural resistance it can arrest, right? So this is all about the overall concept of the development. Here we are going to see about the introduction, literature review, and what are the various materials and methods he adopted to manipulate the behavior of the ECC membrane, and the results, the investigations with respect to various kinds of SEM analysis and differential scanning calorimetric analysis and thermogravimetric analysis, and by making the specimen under the ASTM test. So concluding remarks, and in our laboratory, we have developed, actually under the supervision of Dr. Krishnaraja, the students has developed a thin membrane, and they have analyzed for how bending it is resisting, right? So these are the coverage we are going to do with. And engineered cementitious composites, which is normally called as ECC, which is a developing area now. So those who want to pursue the research after the ME, and those who are selecting the topic, right? So nowadays people are finding very difficult in selecting the topic. So it is a booming area. Those who are really interested in FRC and bending resistance analysis, you can go ahead with this. It is otherwise known as bendable concrete, which is one of the high performance fiber reinforced cementitious composites. We know that cement, there is a difference between cement and cementitious. So cement means only the already available, right, cement like OPC we are using in a box compounds like C3A, C3S, C2S and C4AF. And what is meant by cementitious? Cementitious is nothing but the particles what we are replacing with the cement should possess a property like cement. I'm repeating, the material what we are replacing as a substitute, right? It should possess the property like cement in terms of fineness, in terms of consistency, in terms of setting, in terms of binding, in terms of hydration, right? So all the cases, pore filling effect, like that. So that we are inducing the cementitious material like fly ash, silica fume, GGBS, etc. as a partial replacement to the cement. So it is a cement based material, contains a following mix of cement, fly ash, silica fume slag, as I already told, fine aggregate, water, chemical admixtures, and reinforced with randomly distributed. This is the important, the randomly distributed is the important, right? With a short discrete fibers. Discrete means individual fibers, and you can fix the aspect ratio. If you want to carry out the research in your upcoming days, you can fix the L/D ratio, aspect ratio, and you can modify the analysis, what is its behavior. with fiber volume fraction up to 2%. So if you see that in IS classification as well as ACI classification, they will differentiate the volume fraction into low, medium and high. So here in this study, he has fixed the maximum percentage of fiber as 2% to the volume, right? So these are the ingredients and basic concepts about the ECC. First of all, we have to know what is the difference between the FRC and SIFCON, slurry infiltrated concrete, and ECC. See, in FRC, overall, what we will do, as I told you earlier on 13th, there will be a concrete. In that concrete, we will use the fiber, that is randomly distributed fiber, right? And we will pour it, we will spread it in all the ways, and we will assume that the fiber has been mixed in all the places. Like that, we will do. In SIFCON, initially the fiber will be poured or placed, and cement grouting will be poured in the already placed fibers, right? In table, what you are seeing now, it clearly indicates first parameter for the fibers used. The different types of fibers are glass, steel, carbon, PVA, polypropylene, polyethylene, natural, etc. So these kinds of fibers I have already shown you in the 13th session, right? Including the photos. In SIFCON, they will mostly go for hooked end fibers, that is steel fibers, right? Flat end fibers, corrugated fibers, right? Twisted and deformed steel fibers, which will have more capacity of arresting the shear, right? And for ECC, most application of fibers are PVA because it induces maximum tensile strength to the composites, polypropylene, steel, polyethylene fibers. So these are some of the fibers normally used for the ECC research. The volume fraction is concerned, maximum for FRC, they will freeze up to 3%, minimum with 1% of the fibers. And SIFCON 7 to 15%. I already told you that in the mold or in the specimen, right? Initially the fibers will be filled. Then the grouting will be made. So the volume of fibers will be more in case of SIFCON. So that is called slurry infiltrated concrete. Infiltration means we are pouring inside the already poured fiber matrix. And ECC, so mostly 1.5 to 2%, right? It is used. And length of fiber is concerned, based on aspect ratio for FRC, 20 mm, that is 2 centimeter to 6 centimeter. So already I shown you, right, in the 13th class, mostly 5 centimeter fibers has been used for FRC. That is hooked end fibers, right? For SIFCON also 20 to 60 mm. And for ECC, just note it down, greater than 20 mm. Minimum, it should be greater than 20 mm. It should be used because here we are making as a thin membrane. Here we can raise the question that why we are minimum going to the restriction of 2 centimeter. Why not 1 centimeter fiber can be used? Since we are going for a very thin membrane, when we are giving a 2-point loading, in abroad they will call it as a 4-point loading. They will consider the supports as a point of action. When we are giving a 2-point loading at a 1/3 distance, pure bending concept, so you will experience a sudden deflection at the bottom zone, a flexure zone. So the outer fiber tends to a maximum elongation. So in order to resist that gap, that is called bridging the gap, right? So minimum 2 centimeter fiber is used. That fiber will get the connectivity between the cracks, right? So that here minimum 2 centimeter fiber is used for the ECC membrane. Diameter of the fiber 0.03 to 0.6 for FRC and 0.2 to 0.6 for SIFCON and greater than 0.05 for the ECC. Here we can raise the question that if we are increasing the diameter, for example, it will be in a randomly orientation, right? In a 360-degree quadrant. In all the quadrants, the fibers will be located. You can't restrict either in x-axis or y-axis or z-axis, right? So much amount of fibers also very danger to the concrete. It creates agglomeration and like ball effect will be created. What is maybe ball effect? All the fibers will be clubbed together and will be stagnant at one place. So initially we will assume that all the fibers are randomly distributed and it is evenly placed in all places. But microstructurally, if you see that if the volume of the fibers is increased depend upon the maximum limit, it creates the ball effect. That is clubbing of all the fibers and stagnant at one place. And the fibers will not place at the remaining area, which create non-taking of the flexural strength, right? And tensile strength is concerned, and tensile hardening, flexural strength and modulus of elasticity, it is clearly given in the thing. And it is modulus of elasticity is giving in GPa, if you want to convert in MPa, into 1000, right? Now, we need to understand what is the structural applications of the engineered cementitious composites. We are making ECC in a different iterations, but we need to see where we can use it out. Whether we can use it in our superstructure for the framed element, or in what area we can use, or whether it is possible to go for precast element. So as per Victor Lee 2019 publications article, he has classified the type of infrastructure and what is its application, where it is location, and what is the problem it is solving. The type of infrastructure is for example, if you are considering the transportation, the application is viaduct damper retrofit. So you know that viaduct, it is similar to bridges, right? All viaducts we can classify as the bridges, but all bridges are not viaduct. Hope you people know that it is a bridge made in a different connectivity, as a short span connectivity, right? Which is made across the valley or river, right? So that is called viaduct. So location of the infrastructure, if you see that it is made in Japan, Shisho bypass, what is the problem it is solving? Why they have used for the transportation in that particular place of bypass? So avoid the collapse of viaduct under seismic loading and reduce corrosion in the structure. So here we are having one doubt. So here we are not adding any vibration absorbing material. We will think like that. But inside we are adding what? Right side you can see that steel fibers and hybrid fibers we are adding. We know that steel is one of the material which will holds the vibration, which will arrest the vibration. So your damping will be good enough, right? So hope that the damping as per Newton's law, F equal to ma, right? So without the provision of the fibers, your structure will experience a quick destruction or deterioration. So your equation of motion will be mx double dot plus kx will be 0, the equilibrium equation. When you are introducing a damper, right, that is C factor, if you are introducing. So your equation will be mx double dot plus cx dot plus kx equal to 0, where k is the stiffness. If you are introducing the damping factor, your mass will be stable, your stiffness will be stable. If you are not introducing the damping factor, then the mass and the stiffness will be in an oscillation. So first half is avoid the collapse of viaduct under seismic loading, because when you are making the bridge, your height will be more than 5 meter, right? Minimum more than 5 meter. If there is a tsunami or if there is a vibration is coming, it should the bridge should get satisfied, right? And reduce the corrosion in the structure. Earlier day I have told you that corrosion is happening because of the difference in pH. One thing, how the difference in pH is happening. If small crack is coming in the flexure zone, the contaminants will migrate inside the crack and it will destroy the passivating film of the reinforcement. So when we are going for the advanced concretes like ECC, you can reduce the crack such that the external contaminants will migrate inside. So you can protect the steel, right? Next. Another condition, it was used in USA, applicable in shear key, where we can know the shear key which is provided at the retaining wall, right? What the function or problem it is doing? See, it prevents the water and de-aging salt leakage and protecting the pre-stressing strands against corrosion. Because when you are going for bridge analysis, pre-stressing minimum in our Indian condition, we are going with minimum M30 grade concrete. And pre-stressing strands, we are using for greater than 1000 MPa stress. 2 times or 3 times, even 4 times greater than our normal steel. And you know that the purpose of shear key, which is nothing but it is one of the structural element which is introduced in a structure to stable against lateral loads. To stable against lateral loads like wind and earthquake. Right? So it is normally used in retaining wall and all the kinds of structures where the seismic force, or in IS 1893, if you see that if the seismic zone is coming around 3, 4 and 5, right, it is must to use the shear key. And by using the ECC membrane with shear key, we can able to preserve the pre-stressing strands against corrosion and minimize the maintenance of frequency and the cost. So the maintenance cost will be lesser. So this is the problem they are addressing in the transportation by using the shear key. And water infrastructure for retrofitting purpose in Japan, what the problem is solved is avoid the leakage of the dam and extend the service life of the dam, right? So dam, the leakage prevention is most important in case of dams, all the kinds of dams, right? So by dense manufacturing of the membrane like ECC with hybrid fibers, we can able to arrest the leakage. And similarly, they have given for all the cases. For example, water infrastructure which is made in Germany for repair of hydraulic power plant reduce the risk of cracking and water leakage. So all the conditions, if you are putting in a single point, they are more strong enough to arrest the crack. If you are arresting the crack, you can safeguard your structure in all the times. But we are coming with questions like, if we are going for ECC, whether the structure will be stable for 5,000 years or 10,000 years. No. This is the concept as similar to seismic design. What is our seismic design code is telling? Ultimately, we need to safeguard the people by giving the time to escape. Like that, ECC membrane also. To the maximum extension, how we can preserve the structure without forming of the cracks. Right? Here, there is a confusion between the bacterial concrete and the ECC. On 13th, I told you that bacterial concrete also one of the element to arrest the crack. Then we are arising with the question that what is the purpose of ECC? See, bacterial concrete will not arrest the surface crack. Right? If the crack is forming at the surface, either in the roof slab or the floor slab or the pillar, anything it may be, it will not arrest the surface crack. It will arrest the crack only a hairline crack, HAIR, hairline crack, by secreting the saliva called calcite, calcium carbonate. Right? It will form. That too, please be very careful. If your surface crack is already formed before the arresting of the hairline crack, the contaminants like carbon dioxide will react with calcium hydroxide. Precipitation during the hydration tends to form carbonic acid. That you should be very clear. How we can make the clearance like? For that only, you need to optimize these materials. For that only, you need to optimize these materials by making various iterations. So my humble advice, don't go immediately for the experimental work. Before that, make the trial and error using the softwares. You can go with Excel software, or you can go with the MATLAB software, or ANN, artificial neural network analysis, or ant colony algorithm. Right? So there are different optimization softwares are available. Even you can develop your own C programming coding, make the filtrations and get the optimization results. Go to the experimentation work and find that whether the simulated work as well as the experimental work gets matched. Right? So in abroad, they are first going for simulation study using their own coding. Or if you want to have the optimization, you can have the triangle chart. Mostly they will go for fine-tuning the cementitious materials. How to fix the fly ash, how to fix the silica fume, how to fix the GGBS, like that. Ternary chart. That is called ternary chart. TERNARY, ternary chart. Right? So we will see some of the literature background, one or two literature background related to the importance of the ECC or bendable concrete. Here in this ACI Material Journal, which is one of the very topmost journal in American Concrete Institute, where they have used high volume fly ash more than prescribed limit. Here we are using as per the regulations, not maximum than 27 to 30% as per the replacement of the cement. So in this HVFA, high volume fly ash, to improve the ECC, they are concentrating on two properties. One is called mechanical property, another one is called greenness. See, what is called greenness? So greenness is nothing but green material, not in color, in terms of a pure material, a potable material, right? So it should not get affected in all the cases. That is called green material. See, all the ingredients what we are using for the concrete, not only for ECC, I am telling for concrete, we can't call them as a green material, right? So here they are studying HVFA, and the parameters are mechanical property and the greenness. In this, they are developing the high performance fiber reinforced cementitious composites, right? They are using more number of fly ash, considering the environmental sustainability considerations. So there is a software called GEMS software. GEMS, GEMS, GEMS software. You can note it down. It is a software which was taught when I attended long back ago the training in IITM. So in this software, you can able to give all the kinds of ingredients, concrete ingredients like cement, sand, so and so, including the fly ash, GGBS, all the kinds of cementitious material. There will be a separate category of cement as well as cementitious material. And you can also give the percentage of CO2. If you people are located in the very contaminated area or near to industries, there will be an emission of CO2, right? So what will be the action of CO2 in the building that you can able to give? There is a provision is available in the GEM software. So what my suggestion is, I already told you, you can either go for ANN or artificial, that is MATLAB or C programming coding. You develop your own coding algorithm with the help of ternary diagram, get the optimized parameter. In the optimized parameter, you just give it in the GEM software. And there will be two lines will be there. You can raise me the question that what is the benefit of GEM software? GEM software is also one of the optimized software which will tell whether the selected ingredients is good for concrete or not. So from the optimized result, you just incorporate as an input to the GEM software, and you can able to get the line, blue line and red line will be there. Blue line and red line will be there. If two lines get coincide, right, without having much gap, then you can say that the selected ingredients is best for your mix. I'm repeating, if the two line, red line and blue line, if it is getting coinciding, then you can tell that the selected ingredient is good. If it is not coinciding, then somewhere there is a problem between the dosage. I will give you example. What will be the problem will be the dosage. For example, you can take 1 kg cement. Whether you can add 10% of super plasticizer to 1 kg of cement? No. Right? So if you take 100 gram of cement, say for example, you can take 1 kg of cement, whether you can take 0.001% of super plasticizer? No. That is the gap. For the selected dosage, how much amount of the chemical adhesive I can add to the concrete. So our ultimate objective, not only to the strength, to the high performance, considering the environmental sustainability. What is environmental sustainability? Zero carbon footprint. right? So there should not be any much more emission of CO2, right? And next, cured in air at room temperature before testing. It is called ambient curing. See, what are the type of concrete that resembles the ambient curing is, you can go for geopolymer, where the polymerization is happening due to the incorporation of the two chemicals like sodium silicate and sodium hydroxide. In addition, the main important is we are not using any kind of cement. We are using only the cementitious material like fly ash and gradation of aggregates we are using. And we are calling that concrete as a ambient cured concrete. Just after making the concrete, you just placed it in the ambient temperature. In some theories, they are keeping it in the oven, right, for the comparative analysis. So here we are experiencing on doubt. Ambient curing, it is okay for the in situ concrete as well as for the precast concrete. But oven curing, where it can be applicable, it can be applicable only in the precast elements for the casting of different types of T-beams, slabs, culverts, etc. Making a perfect autoclaving, and they are bringing to the site. You can't find any shrinkage cracks because all the temperatures are maintaining. So from their test results, what they are observing is increase of fly ash content reduces the strength of ECC, right? You people know that increase of fly ash is good in terms of long-term effect, but you can't get the strength in an immediate way like OPC, like rapid hardening cement. Why it is so? See, when you are going for OPC, right, you will get CSH. Say for example, when C2S is relating with the water, if you are getting CSH roughly around 70% in the overall volume, and 30% CaOH twice is precipitating, right? When you are adding cementitious material like fly ash, what it will do is that fly ash will react with the calcium hydroxide as a secondary hydration. Like as a secondary hydration, the running time of the concrete after sitting, then it again forms CSH. So the time gap is the one where if you are adding fly ash, it takes long time for getting the strength, right? But in terms of sustainability, the addition of the cementitious material will give a clear picture because it acts as a pore filling. Because of the size of the particle, it acts as a pore filling. So if the pore filling effect is good, your migration of contaminants will not be there. Automatically your environmental sustainability will be good. Anyway, in the plastering area, what we are doing, there will be a slight carbonation effect will be there. But that penetration will not induce inside the core concrete, right? Since they are making for 1:3, the plastering, that area, there will be some voids will be there. Through that void, CO2 will enter, even though if you are using different types of concrete. But when we are going for ECC like material, the densification will be happen because of happening the secondary hydrations, right? So your membrane will be environmental friendly. So high fly ash content leads to reduce the crack width in ECC. Increase the amount of fly ash in high volume fly ash, ECC tends to improve variability, the robustness of tensile ductility. The bonding will be good, right? You can raise me the question that how the tensile nature can be improved for the concrete. They are not pointing for only for the concrete, because concrete, the tensile nature will be not in order. So they are pointing only for ECC. So ECC blended, the fiber blended fly ash ECC tends to improve the ductility. So coming to the impact resistance, most of the people, they are not knowing about the importance of impact analysis for their research aspects or for the projects, right? See, impact analysis is most important when you are studying for seismic designs, when you are introducing the different class of fibers, when you are making the retrofitting or wrapping, either you are going for U wrapping or flat wrapping, anything it may be, the impact analysis is much more by using the drop down test. So he is studying the impact resistance of hybrid fiber ECC by Kin, Tsoe et al. For the panel, right? A lightweight panel or a normal panel he is doing with, and it was published in Composite Structures 2013. So it experimentally investigate the impact resistance of new hybrid fiber ECC with 1.75% and 0.58% hybrid fibers. So 1.75% of PVA and 0.58% of steel fibers, where altogether it is crossing around 2.5, around, right? Around 2. So maximum they are fixing for 2.5%, right? To evaluate the impact resistance capability of new ECC material, the impact response of plain concrete panel and hybrid fiber ECC panel were compared, right? So normal panel will be your thickness will be not monitored, a conventional thickness. In ECC panel, your thickness will be reduced because in University of Michigan, they are doing lot of activities in the ECC type of research. You can just browse it in the YouTube. You can see ECC membrane analysis. I think an Indian person only, I think so, but I'm not very sure. From University of Michigan, he is testing the panel for flexural analysis. And you can see that the bending will be too huge, bending resistance will be too high without the reinforcement at the flexure zone, right? Only because of the addition of fibers, the bending has been withstand for the material. So what the results showing that is hybrid fiber ECC panel absorbed almost all the impact energy compared to plain concrete panels, right? The plain concrete panel, why the impact is not absorbing is your bonding between the ingredients and between the layers seems to be difficult, not in proper, right? Second observation of his paper is strong fiber bridging was observed from the post-impact cracks. See, I already told you that we can spend our strength to the membrane not to form the crack, but crack will be formed. What we are doing, we are prolonging the time to form the crack. If normal panel is getting the crack within a short span, means a well-designed ECC precast panel will form the crack in a very long time. That too, if the crack is forming, the gap can be bridged, right? It will be held, like shaking the hands, right? Hybrid fiber ECC panels able to withstand multiple impacts when compared to plain concrete panels. So if it is resisting ECC membrane, if the first layer is getting for 25 blows, the first crack, the plain concrete panel will get the crack in a very short time, right? And so initially I have shown you the article related to material as a replacement to cement. Second, related to impact analysis to the structural property. Third, I am showing you the flexural behavior of ECC slab with PVA fiber, which was published by Schwan H. Said et al. In CBM 2015 edition. 2015 year of publication. What he's described is, or what he's investigated is, the effect of polyvinyl alcohol fibers on the properties of panels like toughness, compressive, flexural strength, right, of cubes and slabs, right? So this is the one he is observing in his study using the polyvinyl alcohol fibers, right? So PVA fiber, how much he's adding is maximum to 3% he is using, and he observed that the compressive strength decreases as the reinforcing index increases. So normally I told you that you can't find the indication of the compressive strength to your material, right? You can't find the compressive strength of your material. Moreover, your flexural resistance will get improved by using the fibers. As per Ramakrishnan et al. Research analysis, the ECC PVA slabs does not attain the desired ductility due to the rupture of PVA fibers, right? The ECC PVA does not attain the desired ductility, the expected ductility, due to the more content of the fibers. The toughness increases with increase in the reinforcing index. The toughness means, in Tamil it is called kadinattanmai. The well bonding effect. Due to well bonding effect, your membrane can be protected in the emergency cases, right? Next design is waterproofing manufacture. Preparation of membrane in a well-designed waterproof. So matrix designed for waterproof ECC by Xingyu et al., which is in CBM 2017 year of publication. It describes about waterproofing technique adopted with ECC. See, normally, don't think that for ECC only we can make it for waterproofing. In normal concrete also we can go for waterproofing analysis, even for if you are using epoxy, right? So you can make it as an impermeable membrane such that your external atmosphere, humidity or something will not enter inside, so that in most of the applications for concrete or steel, they will go for epoxy coating. In steel, you can see that a green color steel rod, which is like a epoxy coated rod, where somewhat your steel will be durable and strong enough compared to a normal steel, right? So here, suitable ECC matrix waterproofing admixture. So in our practical cases also, we are having a resin-like waterproofing agent or the cement-based waterproofing agent, cement powder. So in that cement powder, you can add the substitutes 1:3 like combination, and you can paste it wherever you need, right? Added to improve the wetting property and reduce the sorptivity. See, sorptivity is one of the tests in the durability cases, which we will call it as an indirect permeability test or reverse permeability test. So what is called direct permeability test means if the water is coming through the, or if the water is seepage through the concrete from top to bottom. If I am pouring the water over the top of the concrete, if it is passing inside the gaps, pores or voids, and if it is coming down, it is called direct permeability. Indirect permeability means from bottom to top. It is seepage, capillary suction. For that, what we have to do is, you can take any type of specimen. For example, you can take a cube specimen, what you have created, a 10 centimeter by 10 centimeter specimen, or a 150 by 150 mm specimen. You can take cube specimen, just pour the water in a small tray, just dip your concrete inside the water, only touching the surface by 5 mm. What about the remaining places? Right? Your remaining places should be completely closed by the epoxy. Why it is so? The external atmosphere will enter through the side faces of the concrete cubes. So your bottom faces should place it in the tray up to a thickness of 5 mm subjected to water contact surface, and we are measuring the weight difference. How much amount of water is absorbed in a frequent time period. Initially we have to put the weight, initial weight, then you need to make the weight difference. And at the point where there is no deviation in the weight difference between the previous reading and the coming reading, you can call it as a best result. That is a final result, not the best result, this is a final result. From that you can able to get the final observed reading minus initial reading. How much amount of water has been observed. That indicates your seepage, your capillary suction value, which is denoted by the sorptivity. It is called water sorptivity test. So what they are telling here, so by using the waterproofing admixture for the ECC membrane, it creates, it trigger the wetting property and reduces sorptivity. So reduces sorptivity means what? Capillary suction absorption is very, very less. How it is very, very less? Because the gaps has been filled by the cementitious particles fused with the fibers, right? Next, to control the drying shrinkage, they are using for shrinkage reducing admixture or shrinkage compensating cement. You can go with for in order to control the drying shrinkage. And just a minute. Okay. So they are using for shrinkage reducing admixture or shrinkage compensating cement, whichever it may be, and blended with calcium sulfoaluminate cement. Adding of different material is okay, but why we are adding, that we have to take it into account. Because this calcium sulfoaluminate is the material which produce low carbon, and it can be like good environmental friendly material, right? So you can able to get the proper what we can tell tobermory gel, right? So that they are blending the SRA with the calcium sulfoaluminate combination. So water permeability of both uncracked and cracked specimens were examined, right? Obviously we know that cracked specimen will possess much permeability action, Also, you can test it for RCPT in a horizontal mode or 10 centimeter diameter cross 5 centimeter height specimen. You can able to get the behavior of the cracked and uncracked specimens. And waterproof ECC after 28 days curing shows the following: strength around 35 MPa, ultimate tensile strain over 4%. It's good, a better resistance effect, and drying shrinkage results about 2/3 the value of the typical ECC for the M45 grade concrete. Right? So it is, the behavior seems to be good due to the addition of waterproofing chemical in addition to the SRA shrinkage reducing admixture as well as blended with calcium sulfoaluminate. So the next combination is the self-healing ability of the ECC material under different environmental exposure. Zigzag et al. In CBM 2017 year of publication, which denotes ECC normally contains large amount of cementitious material together with self-controlled tight crack width, so it is capable of high self-healing potential. So here we are having a doubt. I already told you that what is the difference between the enzyme addition of self-healing as well as the ECC based self-healing. See, enzyme addition self-healing, we are focusing in the core layer, right, in the core matrix, whereas the ECC based layer, we are focusing in the surface matrix. If we are focusing on the surface matrix, your core matrix also will get stabilized, right? Am I audible, right? Someone can tell me, am I audible?
Yes, sir, audible.
Okay, thank you. So to further accelerate this potential, addition of hot water 60° and CaOH solution, right? So hot water curing, this is nothing but the hot water curing, right? So hope you people know that, as I already pointed in the 13th class, different types of curing suggested by IS 456 in the class 13.5, like membrane curing, steam curing, polyethylene wrapping, in order to preserve the escape of moisture from inside to out, for making the better hydration. So here they are using the addition of hot water at a degree of 60° centigrade as the accelerated curing. So investigated for self-healing behavior under different environmental conditions. So in our IS 10262, right, 2019 code of practice also, we can able to see moderate, severe, very severe, mild, and medium, different environmental conditions. So this environmental condition seems to be very important. See, we cannot come to the conclusion that if we are adding the fiber, but we are adding the wrong dosage of water or wrong dosage of chemical admixture or wrong dosage of mineral admixture without having the proper iterations or simulations, surely the crack and disturbances will occur. So if you are making for severe condition or very severe condition, assume that you are using the concrete for very cold climate, right? Your moisture level will be good there itself. At that time, if you are adding more water, your setting time will get problem, and addition of fibers will be of waste, right? So if you are adding if you are using the ECC for the place where it is very hot climate, if you are adding very less water, there will not be any hydration. Still, if you are further adding the chemical admixture, it will not be sufficient. If you are testing for marsh cone analysis to get the optimized percentage of SP, that is water reducing admixture, you should be very careful in choosing the environmental condition where you are going to place with, right? And he is examining the compressive strength, the degree of fly ash reaction, that I already told you, how much effect of secondary hydration is happening for getting the CS sketch. Care should be taken that there should not be any inert material, right? the material what we are adding as a substitutes for cement, it should be reactive. It should not be an inert material, right? And non-evaporable water content of ECC. See, non-evaporable water content is the one which is prime most important when you are testing for internal curing analysis. You need to compute not only for internal curing, for all the cases you need to compute what is the condition of evaporable water from the surface, what is the condition of non-evaporable water from the surface. We are not doing in our research, right? So the participants, those who are really need to have the knowledge of evaporable and non-evaporable water for the paste conditions as well as for mortar, I can give you more input. Because of the time restrictions, I am not going in depth for these kinds of analysis, because why I am telling is these kinds of non-evaporable and evaporable water itself, you can make a paper, you can make the research, right? So this condition is occurring due to the mechanism of the bleed water to the surface, right? So if you are doing the more compaction with having the concrete a high workability, then your water will come to the surface and your evaporation will be more. You have to manipulate with the comparison of evaporable and the non-evaporable, right? So non-evaporable water content of ECC cement, fly ash paste, so that I told you for it is applicable for the paste as well as for the mortar if you want. But care should be taken that the grinding of the particles should be very fine, right? That should you need to make the what is called grading, and you need to plot and how much amount of fines you are getting. That fines you need to react with, you need to mix with the cement with the proper dosage of water. You can go for the estimation of non-evaporable water, right? And there be a formula is there, right? So examine the different conditions. So what is the observations, their outcomes they are calibrating is, see, calcium hydroxide solution and 60°C hot water effectively increase the compressive strength. Fly ash reaction degree. So fly ash obviously reacts with that calcium hydroxide. And total amount of hydration product. See, just see that. Why we are adding fly ash? It proves that fly ash reacts with the calcium hydroxide presence of 60°C. Again, it forms the good quantity of the hydration product. Automatically, the self-healing process also accelerated. So your bridging is tight enough, right? So finally, they have proved. So in different parts of the literatures, I have covered you. And now we are going for the need, the purpose for the study. Every research, there should be two things, the need and the gap analysis, right? So it should be coincidence. Based on the gap analysis only, based on the need only, gap analysis can be framed. The application of ECC can be expanded for various infrastructure sectors in the future. There are certain limitations in application where monofiber, a single fiber, ECC is used, and so there is a need to improve the properties of ECC with the monofiber. So I already told you that many researchers are going on with only one single fiber and the hybrid fibers to analyze the mechanical, chemical, and durability properties of the ECC. So here polyethylene, PVA, polypropylene have better performance in strain hardening effect, right? Ductility with least amount of load under tension, right? So for the least amount of load, your structural property is getting enhanced by using the above type of fibers, which is mentioned by Victor Lee et al. In 2001, right? And the high modulus fibers, so these and all, the above term, I told you that these and all low modulus fibers, the E value, and the high modulus fibers like glass, steel, and carbon fibers. Nowadays, I told you that you can get the fibers from Go Green Fibers in Chennai. They are supplying these kinds of fibers, all the kinds of fibers in a shredded form as well as in a matte form. So glass, steel and carbon fibers exhibits high tensile strength, that is beyond 1100 MPa. And automatically your toughness will be improved and build a brittle nature which does not allow for strain hardening and ductility effect as pointed by Swami in 1992 and the different authors like Oiden and Ederle 1993. So here browser has been made to develop a new cementitious compost by incorporating different modulus fibers. So they are clubbing the low modulus with the high modulus fibers in a different ratio that I will show you in order to improve the mechanical properties as well as the fluxural behavior of the specimen. So what is their objectives? To develop the new hybrid ECC mixed design with a different modulus, as I already pointed, low and high, to study the mechanical and fluxural properties of the ECC with fibers. So what are the materials they are taking? They are taking OPC 53 grade cement, they are taking the fine aggregates, they are taking coarse, so on so. And mineral admixture they are restricting only to class of fly ash because they are not going for the other mineral admixtures like silica fume, metakaolin, GGBS, quartz, like that, right? So they are restricting the mineral admixture only to fly ash. Because why they are restricting means, if you are taking the other conditions of the mineral admixtures, the research area will be more. So he is taking one mineral admixture, 153 grade cement he is taking, he is not going for 43 or 33, he is restricting that too. He is not going for PPC, because PPC if we are going, it already incorporates the having the like 22 to 24% of fly ash already has been incorporated there, and he's going for OPC and separately for mineral admixture class F, and SP he's going for plus SP 430, and reinforcing steel he's going for FE 400, FE 500, where the ultimate stress is 500 MPa. And fibers, he is using 4 kinds of fibers, that is PVA, polyvinyl alcohol, polypropylene, steel fiber and the glass fiber. And you can able to see the different corrugated fibers as I have pointed in the application study. No, here from this I have pointed in the ECC the steel fibers like that we will use, and this is the corrugated fibers, polyvinyl, polyalcohol, polyethylene, like that different fibers they are using with. And this is the physical property of fibers as per the supplier specifications, like the length of the fiber they are using to 12 mm, and PP, glass fiber, steel fiber, they are going with as per the supply specifications. Here we will have one doubt. Surely if we are changing the basic ingredients, basic properties of the fiber, that is length to diameter, the ultimately your mechanical property will get differ. That is obviously true, right? So here maximum 2 mm difference is only coming for the length for the different class of fibers. The diameter you just see 39, 37, 300 micrometer it is coming, and correspondingly just see the aspect ratios and tensile strength. These and all as per supply specifications, not performed in the laboratory. And MPa in terms of Newton per mm square for just see the glass. As I already told you, high modulus fibers and as we have seen here, high modulus glass, steel and carbon, and low modulus will be comes under PV and PP. So high modulus fibers, if you categorize from the descending order, glass fibers stand in first and 2200 MPa, and steel fiber 2000. And if you are seeing polyvinyl alcohol, it's like a white ivory color material, which is in 1600 MPa, and PP polypropylene, which will be very less strength, coming around 400 MPa, right? And you can see the density also, right? So obviously PP possesses the less density, right? So we know that the density and strength is interrelated. As the density is more, the strength will be more, because the basic concept of stress equal to load by area, right? So the specific gravity of these materials is more, so that the tensile strength is more, that we can able to relate with the density. And you can see the melting point, the point at which the material tends to melt, right? So PP possesses the low melting point of 165 degree, and the maximum tends to 1121 for glass and steel 1370. So shows less elongation, right? The resistance is more, right? Mixed proportions he has created for M30 grade concrete as per IS 1026/2012. Earlier when he did, he has used the code of mixed design code of 1026/2012 version. So for conventional concrete, he is taking the cement as 380. Not it should not go beyond the material prescribed in the IS code of practice. Fine aggregate 711 and coarse aggregate 1283, and water binder ratio is 0.42, right? So 0.44 or 0.42, anything it may be, and he is restricting the percentage of SP to be 1. So what are the conditions, materials he is restricting? He is not going with various percentage of SP. He is fixing to 1%. He is going for the standard type of cement as 53 grade. He is going for class F fly ash, and what he is wearing the type of fibers, right? And for ECC based mix, what is the difference we are finding? What is the difference? We are finding only the removal of the coarse aggregate, right? If you mix the coarse aggregate, automatically the membrane height will be more, right? So here the coarse aggregate is not being used in the ECC. Instead of, the ratio has been given clearly, 1:0.43 is to 7.11 is to 0.35, right? And percentage they are fixing as the SPS 1%. How they are fixing? Here there is a big question for us. Surely we need to go for Marsh cone analysis, right? So based on the Marsh cone analysis, you will have, I think you know the procedure. Yeah, there will be a funnel like arrangement will be there, and you need to place the beaker, right? You need to place the beaker inside the that is below the funnel, and you need to collect the already filled place. You need to make for 1 liter. Then you need to mark the graph for how to time taken to fill the beaker. Based on that, the threshold value you need to take it out. That is based on the Marsh cone test. So if you want to have in-depth procedure of Marsh cone analysis, you can able to refer the YouTube, and more documents are available. So specimen details, he is going for dog-legged specimen. This is called the bottom photo. What you are seeing is called the direct tensile strength, where in our laboratory for teaching of the students, we are going for prism type analysis, right? 50 cross 10 by cross 10 PL divided by BD square analysis is for indirect. It is called flexural test. So indirect tensile test, we will go for 30 centimeter cross 10 centimeter, 15 centimeter cross cylinder, where we have to place transversely, and we need to place the plate or strip, not the plate. We need to place the strip over the cylinder, and the load should be acted through the strip at a L/2, and care should be taken. The strip should be in a length of 1 feet. And the loading ram should be exactly placed over the strip. There should not be any double side overhanging specimen. And when you are giving the load should be like a UDL, right? And you can get the mechanical property from IS 516 code of practice, right? and the splitting will be happen from that 2P divided by PLD. If you mark it out, that is P is the load which is acting over the membrane, and pi LD, pi is circumference, and L length and diameter of the specimen. L is the 30 centimeter and diameter is the 30 centimeter and diameter is the 15 centimeter. So what we are doing is a splitting will give, and we are getting the indirect tensile strength. Here, what we are doing is we are going for direct tensile strength by doing the, it is called dog-legged specimen, where the dimensions of dog-legged specimen is clearly given in the photo specifications. The top dimension is 60, right, mm, and you can see the other part of the thing, and the cross section you can able to get it in the side view. If you see that, you can able to get the cross sections, and the remaining elements what he has gone with is 7 different types he's gone with, and compressive strength going for 70 mm by 70 mm by 70 mm. Yes, small kind of cubes for long-term analysis, and for modulus of elasticity is going for 150 mm diameter and 300 mm a cylinder. In order to go for compressometer analysis, you need to fix it in the compressometer. The pivot point should be touched with the cylinder. You need to give the compression load. The elongation can be monitored by the compressometer, and you can plot the deformation graph, and you can stress strain graph. You can able to get the modulus of elasticity, capital E value, that is stress by strain in terms of Newton per mm square. And flexural strength and toughness is going for 25 mm depth cross 60 mm width cross 350 mm length prism. And for bonding between ECC and concrete interface is going for a general conventional 150 mm cube size that I will show you in the upcoming slide. And bonding between ECC and steel is going for 100 mm 10 centimeter specimen, where he is doing for pull-out test analysis by keeping it in the UTM, right? And impact strength analysis, he is going for 60 centimeter cross 60 centimeter slab, square slab, by dropping by 1.6 meter, right? I will show you the photograph. And for finally the direct tensile strength, he is going for dog bone specimen with the below details. So where we can see for every parameters what we are having now, it should be taken from the articles or the code of practice or some other reference. Just like that, we can't fix the dimensions for the cases. For example, if we are going to fabricate our own product, either for tensile test or for compression test or for any other for durability test, many of the research scholars, they are making their own, especially for shrinkage and creep analysis. They are doing their own kind of manufacturing, right? Setup manufacturing. So for that, if you are fixing the dimensions for the mold or something like that, it should be from the reference. So the above details of ECC, it is coming from Shikmin Kuan et al. 2014, Zhang et al. 2014, and Zhuanfeng Pan in 2015 publication. So based on this, he is taking the specimen details for his analysis, and he's doing the casting. See, this is a mold he's already fabricated. This is not the one he's doing with the applications. So he's already manufactured this mold and making the grouting or filling inside the mold. And you can see the ECC prism, where I have told you, 25 mm cross 60 mm cross 350 mm. So 35 centimeter length, and depth will be 2.1 inch, and the width will be 6 centimeter he is going with. And he downward photo in the left part, you can able to see the pull-out specimen, where he is going for 10 centimeter cross 10 centimeter cube, and in the after giving the cover depth at the bottom, for normally what we will give for beam 25 mm or 30 mm we will give. After that, we will placing this can be act as a pillar, right? So because it is a square section, it can be act as a pillar. So you can give 30 mm or something like that. After that, you need to place a 12 mm rod or something inside at a center. You can see in the left side, a rod has been elongated and it should not get disturbed due to its own weight, as the density is more for steel, should not get disturbed during the plastic stage of concrete. That you should be very careful, right? So you can make this analysis for corrosion also, right? By dipping this element, he's slightly went for corrosion, but by keeping this specimen in the NaCl contained water, and you can connectivity the steel positive to one end, negative other end, you can pass the current to 60 volt and you can observe the reading. 12 volt or 60 volt, you can observe the reading, and you can, after the corrosion has been happened, you can have the half cell potential meter, and one end can be connected to the concrete where the copper sulfate solution will be filled in that half cell potential. Another end will be connected to the steel, and you can switch on the half cell potential, that is multimeter. You can able to get the reading in terms of millivolt or volt. So based on ASTM C516 code of 596 code of practice, you can able to get the potentiality, how much percentage the concrete corrosion has been happened. And if you see that last photo, it is mentioning for ECC slab, right, for impact test and cube specimen, where he is meant for 60 centimeter cross 60 centimeter. So this is a sample 7 centimeter cube he has casted on dog bone specimens. It is in the curing and reinforced concrete beam. It is under testing. Actually, it is going for flexural analysis. And he went for the beam analysis, right, flexural beam, where you can see the length as 2 meter outer to outer, and from center to center 1.8 meter here beam, clear 1.8 meter beam. And he used the Spiresta 2-legged stirrups at 100 mm spacing center to center, and the diameter is 6 mm diameter rod he has used, and the cross section you can find at the bottom, where at the 30 mm from the bottom he is using for ECC layer 30 mm thick, right? So remaining place it is filled with concrete, and the depth of the beam is 150 mm and the width is around 100 mm. The main rod is 8 mm diameter, 2 mm rod, and the hanger bar what he is using is 6 mm diameter, 2 mm rod, right? So he is designing for the minimum load carrying capacity of 17.9, where he made his theoretical research that in Excel. So for bond test analysis, as we already pointed out, this is for class number 4, 150 mm cube size, where half portion is made with the concrete and remaining half portion is made with ECC. And we need to understand what is the interface between, a joint interface between the concrete as well as the ECC membrane, right? So this test has been made as pointed by Zhang et al. In 2014. And in the right side photo, you can able to test the bond between the steel and the ECC, where we have made for this bottom left side photo, right, for the pull-out test. So he is making for the bond test between the steel and the concrete as per IS 2770 first revision. Here you can see the impact test setup. This is the one we have fabricated in our lab, this impact testing machine, what the yellow color and the base, that base element, structural element, what you are having, the supporting element, what you are seeing, no, that is that we have fabricated. And this is a drop down test where the standard hammer weight is 7.6 kg, and we are dropping from 1.6 meter. And we have given the provision for drop down. See, if you see that this test actually, this setup actually we have manufactured for egg protection experiment, which is one of the American Concrete Institute game, right, a study game. So we have fabricated for that, and we parallelly using this equipment for studying the impact analysis also, right? So they are dropping at a height of 1.6, standard height of 1.6 meter over the slab, and carefully you need to mark the center of gravity. That center of gravity of the slab should coincide with the center of gravity of the hammer. So why it is necessary? If it is an eccentrical loading is happening, then your crack pattern will be at a different phases. Surely it will get resistance, but the resistance will not be proper. So the impact what you are making should be marked at the center. That center should coincide with the center of the thing. So after that, he has simulated the fiber, the PVA, PP, and glass fiber under simulated pore solution. So as per each and et al. Paper, CSK gel formulation is simulated outside the concrete by dipping the fiber in the combination, right? So he has made, you can see it in the first photo, PVA and PP and glass fiber. He has taken the fiber separately with that mortar and he dipped in the solution. That solution combination is sodium hydroxide NaOH, potassium hydroKOH, and calcium hydroCaOH twice, with the distilled water in the ratio of 8.17 is to 0.83. The balancing of pH at 13.6 for 35 days he is observing, right? So based on how 8.17 it is coming means based on the molarity, in Weichen et al. Paper, you are having all the details based on the molarity, and he is getting that ratio, and based on that ratio he is filling that fiber inside that specimen, the glass tube, and he is observing for 35 days. So it is based on Weichen et al. 2007 year of publications. So here test results for fibers, he is observing for each type of fiber, he is observing for two conditions. One is raw fiber and dipped fiber, right? SPS means simulated pore solution fiber after dipping, and for PP again raw and SPS, for glass against raw and SPS. And you can able to see the physical appearance of the fiber, where the physical nature, the color difference seems to be differed in the PVA fiber, right? So based on he is observing for FTIR analysis, you can get the downward peak where it shows around 2005. PVA it shows around good resemblance up to FTIR means Fourier transform infrared spectroscopy, right? So the downward maximum peak, it comes around 2000 to 2500 wave number, right? So for SP, yes, as well as for PVA, the coincidence can be viewed, right? The second coincidence, for the maximum coincidence for SPS, it is coming around 1000 to 1500, where we can take the maximum number, right? So if you want to make the research for only the FTIR or the microscopic analysis, it can be a separate research. It is possible. You can make the collaboration with the physics people or chemistry people, then or even metallurgy people. In some cases, mechanical divisions, they are using different kinds of fibers, that two natural fibers they are using. You can club them and make the analysis, right? So in the y-axis, you can see the transmittance, how transmitting the wave pattern is, right? And the raw fiber for PP, you can see in between 2500 to 2000, there is a high peak, the raw fiber emittance. So you need to take the highest wave number, highest peak for the particular wave number. If it is crosses beyond 2000, it will be good, right? And you can see the SPS dipped fiber for glass. It is showing around 2400 the transmittance value, and similarly for gravimetric analysis, it is nothing but it is one of the thermo analytical technique. right? Thermal analysis technique, which we will obtain the outcome with respect to mass versus temperature. If you are putting, for example, I am breaking the concrete. I am taking the concrete outside. A pinch of the concrete is placing in the DSE machine, right? With respect to mass, how I am placing, with respect to temperature, how it is inducing. For example, if the temperature is inducing, how the mass is getting, mass percentage, it's not get disturbed. The mass is not get disturbed, that is coming around TGA analysis, thermogravimetric analysis, right? So you can see the different types of TGA analysis. For example, if you take a sample for the first fiber, PVA fiber, right? The mass percentage for a temperature of around 30 degree, your mass percentage is 100. And finally, if the temperature is increasing, right, your mass percentage is around 55. So there is no much difference, much deviations that we can observe for all these kinds of graphs using the thermogravimetric analysis, where DSE tends to the analytical technique where the difference in amount of heat, which is required to stimulate the temperature of the sample, right? It is nothing but difference in amount of heat which is induced or which is essential to stimulate the temperature of sample as a function of temperature, right? So these type of test, differential scanning means if I am keeping the particle in the DSE element, the scanning will occur, right? How much is due to that scanning, how much of particle is getting disturbed? How much of particle is getting disturbed given by the differential scanning calorimetry. And you can able to get the field emission SEM photograph of the raw fiber as well as the SPS fiber. The morphology, the texture, you can able to get it, right? And different types of fibers, you can get the SEM analysis. Not only for ECC, for all the kinds of material, even for sand, if you are using, we are assuming that the sand has been in this grading, but whether it is coming under this size or the texture or the angularity, that you should be clearly mentioned, right? We are assuming as angular, but if the SEM analysis, if it is like rounded, what we have to do? So most of the aggregates, especially the lightweight aggregate coming under the hollow glass microsphere and ceramic microsphere that I have shown you now, the surface will be a very good texture, like what you are saying now. A round like structure will be there, right? So SEM analysis morphology for each ingredient also very important. Just see the mechanical property of the monofiber ECC, where he has classified into 4 fibers, as I already pointed: PVA, PP, glass and steel. For PVA, he is going for maximum to 2.5%, because in one journal he has went for 2.3. So maximum he is testing in our journal 2.5%, right? So in 2.5%, he is going at an interval of 0.5%. PVA 0.5, 1.5 to 2.5. So for that, the fiber volume fraction remaining term PP, glass and steel is 0. And simultaneously for PP, glass and steel, the corresponding fiber percentage volume fraction has been mentioned in this table. Second to 5th column. And for the corresponding compressive strength, E value, direct tensile strength as per dog leg specimen, and flexural strength as per 2-point loading, as per Indian condition. So maximum strength, it was pointed or marked in a bolded color. For example, PVA at 2% volume fraction, if you go, your maximum compressive strength is 51 MPa, and correspondingly E value and direct tensile strength and flexural strength, where in our IS code, FT value you will calculate, right, 0.7 root FCK, right? And similarly, you need to balance with respect to the compression strength for all the different types of strength, like tensile strength and flexural strength, etc. The direct tensile, the difference is direct tensile strength is by giving the pulling load, right, and T value. Flexural strength is all about the bending. If I am giving the 2-point loading, what will be the bending? You can also able to measure the deflection also. For plain concrete is not possible because the bending will be very, very, very weak. Suddenly it will bend. So if you take PP 2% volume fraction around 47.5, just see the row. And for glass 2% 53.71. See, you can now assume that the high modulus of fibers is glass and steel, and low modulus is PVA and PP. In low modulus, PVA shows the better result, and in high modulus, almost same. Glass and steel, almost the same. It's around major 0.5 Newton per mm square is coming as a difference, right? You just compare for the E value also, then direct tensile strength, and even for the flexural strength, right? So just compare the glass flexural strength with respect to steel flexural strength for 2% volume fraction. Even though the compressive strength for glass it is 53.71 and steel it is 54, the slight increase in steel, but for tensiles, for the flexurals and the bending arresting, shows the better resistance for glass than the steel because of the density, as we have already seen here, right? Where we have seen here, yes. You just see the tensile strength is 2200 and steel fiber 2000, and because of this, there is a slight increase in the tensile strength for flexural strength for glass and for steel. And you can also compare the tensile strength 7.98 is 7.24, even just 0.5, 0.6 difference. But why it is so? Because glass fiber is taking 2200 MPa, whereas steel is 2000 MPa, right? For that, a slight difference is getting. But we can't observe, as I already pointed that, you just see, you can't easily observe the variation in the tensile strength. Where you can able to observe the variation in the variation in the compressive strength we can't observe, whereas you can see the variation in the tensile strength we can observe. Some of the readings coming around 4.25, right? And some of the reading around 7 it is coming. Major deviation 3 MPa it is coming, right? So this is the earlier slide is for a monofiber, and this is for monofiber and hybrid fiber. So what he is doing, row number 1 to 4 is he is taking only for the best mix. Here from the monofiber, he is making the volume fraction from 0.5 to 2.5, and for overall observation, he is taking the best results, 2% volume fraction. From that, he is going for the hybrid blending analysis. First to fourth, it is PVA to steel 2%. So in the blending, 5th to 13th, he is making the blending. How he is making the blending? He is taking the PVA low modulus fiber as a best value, because from the previous thing, low modulus is the 151 MPa is coming. He is leaving that PP, right? So PVA, PP. Why PVA, PP is taking low modulus fiber grouping? PVA he is taking for 2/3, and PP he is taking for 1/3. So 66 percentage, around 60 to 65 percentage, he is taking for PVA, and 33 percentage he is doing for PP. Why it is so? We have to raise the question. Here, because PVA is giving the high strength, right? So that PVA is 2/3, he is taking PP 1/3 for 2%. Again, PVA 50%, PP 50% for 2%. PVA 33% and PP 66% he is taking for 2%. Simultaneously for other grouping also. PVA plus glass, PVA plus steel. Now you can able to assume if the PVA he is making as a constant. This grouping, he is not going for the PP plus the high modulus fiber. Why? The PP we obviously know that it's coming around 4 MPa. That's 4.5 MPa only direct tensile strength is coming, and 18 MPa it is coming around flexural strength. So he is constantly fixing that PVA for low modulus fiber and grouping with other fibers. And you can see the fiber volume fraction, PVA, PP, glass and steel for 1:4 combination. And as I already told that 33% is for the remaining things, right? And carefully note that SP and water binder ratio, fine aggregate ratio, fly ash ratio, cement, he is fixing. If you are modifying this ratio, then compulsorily the research aspects, the research parameters will be huge, right? So he is not wearing the mixed design. So from that, he is obtaining the graph, and you can able to see the first combination, the glass 2%, the monofiber. This is for the first graph is for monofiber, where the glass at 2% is given, the maximum ratio, next steel, next PVA, next PP. This graph shows the better compressive strength results with respect to this table. That is getting proved. Coming to the second graph, so the reason behind, as I already told you that because of the good tensile strength of the monofiber, right? The parent material of the glass, for example, if you take the Saint-Gobain glass, it is quite costly. But if you, as already told you, on 13th class, Dr. Sunita Nair, faculty from IIT Hyderabad, under the guidance of Professor Gettu, she also used the what is called that Saint-Gobain fiber. She tested for all the fibers. Again, she tested for Saint-Gobain fibers. You can refer that. So the particle arrangements inside the core layer, as you observed from SEM analysis of that fiber, you can get a good morphology. Then steel, right? The gripness, due to the gripness, your concrete showing the better result. And you can see the target strength. He is designing for M30, but you can able to get the target strength. But all the concretes from PVA to PVA, PP, glass and steel, all the concretes has attained the compressive strength, right? So as I already pointed, compressive strength, it will come, but we have to focus mainly on the bending, flexure and the direct tensile strength. For the grouping, PVA, if you see the pink color, is PVA 2%. If I am clubbing with PVA plus PP at 2%, it is showing the maximum result, right? PVA plus PP, it is showing the maximum result. And I will point to one result which is the very best result, PVA plus glass, because the volume of the glass material they are adding more, right? 2/3, and that is around 65%, and PVA around 1/3, 33%. If they are adding we obviously know that 2200 MPa will be the tensile strength. So the brown color diamond is getting increasing at almost around 50 MPa. Target strength is achieved for M30, right? And if you see for the 28 days for steel, right, it is slightly greater than glass, but when you observe, this is a after the compressive strength analysis of the monofiber, the A division seems the monofiber of ECC, and B and C, it is a blended fiber. And you can see the direct tensile strength where all these categories were observed from this table, right? This shows the direct tensile strength of the dog-legged specimens were tested for many different types of fibers and failure pattern also. You can see the gap bridging, a very beautiful photograph showing the fiber gap bridging of the fiber. Whereas if you are adding bacteria like this, you can't see this kind of bridging gap. It can arrest only the core layer, right? So, and you can see the flexural strength. The table value, what we have studied over there, it was plotted in a graph. So 14 days we have seen here, right? So major testing. So hope you people know that for 7 days we can able to get the 33%, and for 14 days 90%, and for 20 days around 95%. Then you can go for 56 days, 96 days, 90 days testing and all. And they have test for ASTM C1018 flexural toughness value for making the prism, right? A slab material, thin slab material, and for 2-point loading, as per Zwick universal testing mission of 100 kilonewton, you can see the maximum load carrying capacity of 34 or 35 kilonewton, the peak value, and the maximum deflection is coming around 11.9 or 12 mm. So this is for PVA combination of 2%, and the remaining graph shows the, for example, if you take the glass fiber, the ultimate load carrying capacity is around 40 kilonewton, right? Where PVA fiber, low modulus fiber, if you are using, it is around 33, around 10 kilonewton is getting 7 to 8 kilonewton is getting different, but carefully observe the deflection is coming, deflection is reduced. Just see PVA low modulus fiber, if you are adding, the deflection is more, obviously the compressive strength peak, the flexural peak load also less compared to the glass, where your ultimate deflection is coming around 7.9 and the maximum flexural load carrying capacity is coming around 39 kilonewton. And you just compare with the high modulus fiber, just leave that low modulus fiber PP also, just see the high modulus fiber of glass and steel, you can able to get a very less deflection with the maximum load carrying capacity. And this is the combination of all the fibers where you can get the maximum load is for, you can able to get it with respect to the deflection hybridization. And this graph shows a steel of 2% around coming 36 kilonewton and maximum of 7 mm deflections, right? And next to green PVA combination, it's around, so PVA plus steel combination seems to be good, and glass you can see it's in a brown color, and this has been showed in a flexural toughness value, the maximum peak load, and what is the deflection at the peak point. We have got the maximum deflection. You can see the flexural toughness graph where for this slab, after failure, you can able to get this bridging gap, and the different slabs here it is mentioned with, and the bonding behavior between ECC and conventional concrete you can see, and between this is the failure interface, and this is the impact test analysis, and this is the load 5.74 56 Newton. The first crack, it is appearing on 25 blows. First crack, the specimen is failing at the blows of 330 for conventional concrete. So first crack, how we are getting is load into the distance, right? Load into distance, we will get it, and based on number of iterations, you can able to get it. And this is for fluxual behavior of beams. The maximum load that I have shown 1.8 meter beam, right? The maximum load carrying capacity, what is its ultimate deflection, yielding point, and we have to plot the stress strain graph. And here also it is mentioning the maximum ultimate carrying load, ultimate deflection for different. For example, ultimate deflection for PP, it is coming around 48 mm, whereas PVA plus PP, it is coming 45 mm. PVA plus steel, it is coming at 22 kilonewton, and the maximum steel, it is coming 23 kilonewton, it is coming. So initially we have designed for 17 kilonewton, right? In the earlier slide I have mentioned, initially we have designed for 17 kilonewton, but when we are using the monofiber as steel and combo fiber as PVA plus steel, you can have the load excess to the design load. So it is safe. If it is less than 17 kilonewton, we have to monitor. But here, if you point the monofiber as steel for 2%, it is coming around 24 kilonewtons load carrying capacity. And for combo PVA plus steel, we are getting 22 kilonewton, which is greater than 5 kilonewton extra than the design load of 17 kilonewton. So from this, we are going to conclude that from the FTR analysis, there is a considerable changes in transmittance of PV and PP fiber, whereas glass fiber shows the better resistance, right? Since because of the high modulus. So from thermogravimetric analysis, TGA, it is found that raw PV and PP has more residual mass, whereas glass dipped fiber has glass SPS, simulated post solution dipped fiber has more residual mass. And similarly for DSE, and SEM analysis shows that there is no degradation and reduction in cross-section area of the fiber, where the morphology seems to be very good. And in the compressive strength test, steel possesses 6% higher results on PVA than PVA, and hybrid matrix shows PVA 1/3, 33%, and steel 2/3%, shows 4.5% high compressive strength than PVA mix. And you can able to get the modulus of elasticity value with respect to the PVA as well as PVA plus glass. And also for direct tensile strength, the mixture was found to be 44% high strength than PVA, and PVA plus glass shows greater than 25% than P. So what they are doing, they are comparing, they are obtaining the PVA and glass as a better result, and they are comparing with the low modulus PVA fiber, right? And this is for hybrid fiber analysis. So his publication list, and these are the references. So hope I have taken 5 minutes extra. Sorry for that. And you can see here that in the laboratory, under his supervision, the students has developed a thin membrane, and instead of regular support, they have placed a conventional prism, and over that ECC membrane was placed, a hybrid ECC membrane was placed, and over to that loading was given, and you can see the buckling. Here there is no reinforcement placed inside, and you can see the bending. If you remove the load, it should come to its original position, that a ductility based concept. So he is making for trench cover like design. So thank you so much for your patience hearing. So I think I have taken 5 minutes extra than the prescribed limit. So thank you so much. Yeah.
Thank you, sir. Participants, if you have any queries, you can ask.
Thank you.
Thank
Dear
you,
participants,
sir, for your elaborated explanation. That is only I can say because
Sir, actually, your voice is not audible. Is it possible to check your?
yes, now it is audible, sir.
Yeah. Now it is audible.
Uh,
Yes, sir. Go ahead, sir.
uh, uh, Thank you for your elaboration explanation. Uh, Here you mentioned about only in that research only that fibers were percentages varied for engineered cement composite. So
Yes, sir.
can I think of wearing some percentage of fly ash, and is it possible to carry research in that to pursue research?
Okay. So, sir, actually, if you see that, I have shown you the slide. I think based on the time, I will cut short my. Yeah. I think I have shown you the mixed design, right?
Yes, sir.
Yeah.
I seen that.
This mixed design.
Hmm.
Yes. Are you able to see this?
Yes, sir.
Okay. So here, if you can make the variation in the fly ash, but if you are varying, for example, if you are
Sir.
varying the person. Hello. Hello. Shall I proceed, sir?
Sir, my name is Shivkumar. I have one small doubt, sir.
Just wait, sir. I clear his.
Kumar,
One person is
Kumar,
asking the doubt, sir.
another person is clearing doubt. Please wait, Sukumar.
Thank you, sir. Thank you, sir.
Sir, actually, you can able to make the variation of the fly ash. For example, here, if you are going to use the OPC of 53 grade, for conventional, you can use 100% and fly ash percentage will be 0. And for your maximum variation percentage is 30. For 10% if you are modifying, that is 90% of cement and 10% of fly ash, up to, so you will have 3 variations, right? For 3 variations, you need to make the 4 different kinds of volume fractions. For example, each individual percentage of replacement, you need to study for that particular volume fraction. For 10%, what is the 2% of PBA? For 10%, what is the 2% of PP? For 10%, what is the percentage of glass? Like that. So combo will be 13 into 4 matrix. Each individual, you will have the 3 matrix extra. You can do it, but you need to refine it. For that, what I am telling is, I have shown you the different literature review, right? From that literature review, you can take the optimized amount of fly ash, or if you want to go for different kinds of mineral admixtures like GGBS or something like that, optimize the percentage. From the optimized percentage, if you go for analysis, then your fine tuning of research will be easy. Because when you are submitting to the examiner, it will be very tough. He will give more questions for the analysis. That is the right choice. First go for optimization, then you can go for the fiber matrix analysis. Yes.
Okay. Thank you, sir. Thank you very much.
Thank you, sir. Thank you. Yeah, Sivakumar, you can raise the question now. Am I audible, right?
Sir, you are audible, sir.
Okay.
Hello.
Yes, sir.
Hello.
Yeah. Go ahead, sir.
Sir, are you audible, sir?
Yeah, your voice is creating echo, sir.
Sir, just a minute, sir. Sir, now, sir? Now?
Yeah. Go ahead, sir. Go ahead.
Sir, my doubt is, when we use randomly oriented fibers,
Okay.
we experience the balling effect, means it will get balling.
Yeah.
So how it could be reduced? So we tried by reducing its length, fiber length. Is there any other options? Can you suggest, sir?
Sir, actually, just fix the aspect ratio first. Modify the aspect ratio.
Okay.
Right?
Okay.
Then the suitable ingredients, what you are using, as well as the chemical admixture, what you are using.
Okay.
It should be in a optimized, in a compatibility form. For example, I will tell you. assume that you are using 0.43 water cement ratio.
Okay.
If you are adding slight increased amount of chemical admixture, that is more than 6 kg per meter cube,
Okay.
the plasticity, that is the consistency of the mix will be higher if you are going for VMA, that is Master Cliniumsky 8233.
Uh-huh.
If you are going for slight higher percentage than the prescribed limit, than the optimized percentage, then the consistency will be more. Then
Okay.
what it will create is, when you are mixing, the fiber will club one to one, and it will create like a bonding, ball effect.
Okay.
So for that, you should not study only the dosage of the fibers, irrespective of the length, geometrical features, and all its parameters. You need to study its chemical admixtures, what we are using, and what is the type of mode of water we are using. That also we have to take it into account, because it leads to the shrinkage effect also, the ultimate behavior.
Okay, sir. Okay. In literature, these suggestions were not there. It was very
That's what I
helpful.
am
Thank
telling,
you.
sir. That's what I am telling. You can refer a specific person, those who really did the FRC. You can connect with the LinkedIn, or you can refer with the, you can make the connectivity in the Sunita Nair that I told you, no, under the
Yeah,
process.
yeah, yeah.
And also Saktivel, he recently completed his doctorate, and you can refer him the shrinkage and creep analysis, sir. Using
Okay.
the fibers, you can using the fibers.
Okay, sir. Okay.
He
Sir.
also studied for orientation also, orientation of the fibers in different quadrant.
Okay. Okay. Okay, okay, sir. Understood. Thank you.
Okay,
Thank you.
okay. Thank you so much. Thank you. Anything, sir?
If no query, shall we close the session, sir?
Yes, sir. Yes, sir. If there is no queries, we can close the session, sir.
Thank you very much, sir. Thank you very much, Professor Dr. G.S. Ram Pradeep, for a wonderful session on bendable concrete in structural elements. Professor has covered engineered cementitious composites and high performance concrete and high strength concrete. He compared those two, and also he carried out the need for the study. Mainly, he did about the different types of fibers for bendable concrete. What are the different materials used for this bendable concrete? And he dealt in a detailed manner about the various laboratory tests related to bendable concrete. And he also compared the various test results with the help of graph. And there is a very nice interaction between the guest speaker and the participants. It is a very much interested one. Thank you very much, Professor. Thank you, participants. Now the time is 11:15. We will join for the next session after 10 minutes break. That is 11:25 a.m. Thank you, participants. Thank you, Professor. Thank you, sir.
Thank you so much. Wish you all the best, sir. Thank you.
Thank you, sir.